Well, hello everyone. Hey, you can't see my face, can you? I guess we gotta get rid of that hat. You know, hats are great. Oh, by the way, I'm gonna say like and subscribe if you hadn't done so already, and you like what you're seeing. So anyway, this is Rick, and I'm happy to see you guys again. Maybe I need to come up with a handle, like so many people do. But anyway. Yeah, hats are great. I've been using hats for, a couple decades now. Most people don't wear hats. But you know, it keeps the rain off their glasses. It's a good thing. And it keeps it off your neck, too, when you're trying to walk around. It does mess up your hair, though. But I think they're awesome. And you know, the funny thing about hats in the United States, most men don't wear hats anymore. At least it looks like it's maybe taking a comeback. But I read once or saw an article or something a long time ago, and they said to me, I think it had something to do with style. And the reason we don't wear hats so much anymore is because when John Kennedy got elected president, he did not wear a hat. So, as a lot of humans are, style is important. And style was what the president was wearing. He's young, his wife was young, and beautiful people and all that, and so the women started dressing like Mrs. Kennedy, and the men took off their hats. A lot of them did, and it's kind of a sad thing. Out in the West, not so much, but anyway, what I want to talk about today is like resiliency, or what your networks are doing. Like, for example, people are always telling me, "Oh, I got my Starlink. Boy, it's good. I'm good. I'm going to be able to talk to the internet no matter what." And then, "Oh, I got my cell phone," or whatever mechanism. They just want to make sure they got some kind of internet. Now, you probably heard different outages, different things have happened to the internet. And people think that, just because I have Starlink, I'm never going to have a problem with the internet. Well, let's talk a little bit about how these systems work. And it's a satellite system is what it is. And he put a whole bunch of satellites up there, so they're pretty much anywhere in whatever hemisphere that they've put these satellites over, that you can connect to one with their special Starlight equipment. And there's been companies out there that for a long time that's had satellite systems that you could get on the internet or watch TV or whatever. You know, direct TV is internet connectivity, and also the ability to watch your TV and stuff. So let me kind of draw how this works. It might give you a little better understanding, so that you can make a determination whether you want one of these things, given the price, and kind of how it all works. So you've got the planet right down here, and you got the satellites up here. Little satellite up there, like a little critter shining his little. Got his little dish. Let's put a little dish the other way. Yeah, come on. And a little dish up there. And so here's a little this station down here. Got a little base station down here on the Earth, and it's got a dish on it too. So it's got a dish, and these things are talking to each other, going back and forth, sending data and receiving data, back and forth like this. Now, the internet is basically a big, humongous network. It's just a computer network, and they're using data. Voice has now been digitized, so now the voice is on the basically the same network. A lot of the same carrying pieces that you use to get your telephone, go use the same system that the internet does for using computer communications. Now, so down here on Earth, this station, this is the StarNet. Let's call that StarNet up here. SN for StarNet. And it's sending stuff that back and forth to this. So you're over here trying to communicate with it. So you have a little video station and you send a signal up to this guy. And then what it does is it's going to either, I don't know if they're connecting to each satellite, but probably they're just connecting back down here to Earth to a major station that gets the signal. And then inside that, from this point on, we'll talk about that in a minute. I'll erase this picture if I can find my razor. There it is. And so they send down to you. So this is a user over here. Here's you on this nice little happy guy. You know, you're down here with your little satellite, your little cell phone thing or whatever, and you've got a Wi-Fi connection to that thing. And then from here it goes up to here, and from here it goes down to here, and from there it goes to the internet. Now, I know this is a little bit of a technical thing, so I'm going to try to, it's going to get into the pieces and the elements, but I'm not going to get into protocols and, you know, all the things that are involved in making it actually work. So down here at this base level, let's talk about that for a second. I can make the diagram too complicated, so we don't want to do that. So we have your base station, or the antenna that's coming in here, and it's got its little, you know, thing. It's got a box down here, and this thing has got a signal, and it goes into a device. Now it ends up at a device called a router. That's where it ends up, and that router is connected to the internet, the main backbone of the internet. So the big companies like AT&T and well, this used to be Sprint, but what's the right company's names now? Boy, they get Verizon and AT&T are the main boys now, but there's some others out there, and they are connected to this big network that's all across the world. The United States, you know, let me see if I can draw the United States worth a hoot, whatever, like that. And down here they've got these locations all across the country in different places. There's not a whole lot of them, but they have them. And there's tiers of these. So you might have a bunch of local ones, and then they go to, and eventually though, there's this network that's here. All these major players are tapped into this thing. And all the data, so that if you're down here and you want to connect to a device over here, I'll say it's a server, somebody put a server over there and you're a workstation over here, you want to connect to that, you've got to go back to this big network right here, which all these things are interconnected in a big network. And it's got to send it over here and send it down here. And then the response will come back, and it'll come back, may or may not come back the same way. The routers have got software in them, not the little router at home, doesn't have much software, but the big routers do. They have a routing capability, and they're able to decide, well, what's most probably the best efficient way to get from here to where you want to go. Now the thing about this is, it didn't used to be this way. And what we used to have is, if you were at your old little in your town, and you had your little PC here, and it's connected with a modem. Well, y'all might not know what that is. You actually have one in these routers and these cable modems, called cable modems. But you have a modem, and it would dial up and connect to another modem. And it would make this connection, and I use a lightning bolt for that. That's the standard industry for making that connection, so you don't have to put all the pieces in between. But what these pieces would represent would be your local telephone exchange. So down in a lot of little towns, you can find these, and the big cities are huge, and they're all in big warehouses and what they call colos. That's a colo is a big building with a bunch of IT stuff in it from different companies, and they're co-located in the same building. So that's why they call them that. And they can connect to the internet. Maybe you bring a big old pipe in there into that building where all these companies have their servers inside there. And makes it a little more vulnerable, but they can back it up more frequently. So anyway, from your PC, you would go to this little building downtown where they used to have the telephone operators. And you're using their telephone line, so you just connect to that, and then it goes from there and connects to the modem, and here's the other guy's PC over here. And nobody's watching you or can see it. If you want to tap into seeing what they're doing, you have to get a warrant, and you have to tap the telephone line. Well, this is all going on in the... And I guess in the early 90s, and the government decided to allow the people onto the DARPA net. DARPA, DA Defense, and I don't know the rest of it. Rest of the initials, y'all can look it up. But there was a military network, and the schools and research groups had access to that network, and it had existed for a while. But it used the IP protocol, which is why we use ITP. It's IP protocol now, TCP and IP. If you don't know what that is, that's okay. It doesn't matter. But basically, think of it this way: it's not exact connection, but it's like language. Even though it's not a language, it's called a protocol. Anyway, this device is talking to here, and so people would set up servers over here, a whole bunch of servers. I have a whole bank of these, a whole bunch of telephone numbers in this place, and a modem, and then they would have them where these modems would be hooked up to their PC that they'd have at home, and they'd have some software running on here, and so there'd be a bunch of people out here, different PCs, and they're all dialing into this thing. And so here we were sending stuff to each other. You're sending videos and pictures and text back and forth. You get on and you chat with people and all this sort of thing. No government involved. Well, so what they decided to do when they released it, I think they didn't want you having a private network like this. So they decided to build one, and then everybody gets on because it's so easy. You know, it's the way that's the game that everybody that's always played to get you hooked, make it easy for you. Amazon, that's a perfect example. Man, they make a ton of money off of everything because they are easy. And people will give up their freedom for easy. It's almost the same concept the founders talked about. It's giving up your freedom for a little safety. But it's really perceived safety, not perceived easy or perceived safe or actual safe. So anyway, so this is how it was working. Well, when they opened that up, then all of a sudden that killed all this. And it didn't kill this end of it, but it killed this much, pretty much. And then what they started doing is they built those big old facilities at these big locations. And the big things, where all the schools were connected originally, well, they started building out big structures. And they had MCI and Sprint and different places like that. Now, air conditioner just kicked in, so it's going to make a little noise for a minute. I'll tell you what I'm going to do. I'm going to pause the video, and then I'll turn off the air conditioner so it makes less noise. Okay. So, anyway, when they changed it, you had a lot of big companies that were out there, and they were trying to get your business. So they were tapping into the internet and into the DARPA net, which now got renamed to be internet. So what is the internet? You know, everybody talks about, oh, I have a cloud out here. There's a big old cloud. Oh, boo, it's a big cloud, scary thing, and we don't even know what it is. It's magical. I think Kamala Harris, oh, it's like it just goes up there and it's processing. I think she was going to bend over there and start worshiping it something. But it's not God. It's just a big bunch of network, a bunch of servers and networks that, and I mean, routers and switches and things plugged into each other. And it's just got built a little at a time. You build something, you build a piece of it, and then you connect that to another thing, and then you add something to that, and before you know, and you keep doing that, and eventually, before you know, this thing looks monstrously complex, and it is complex. But the fundamentals of how it works is pretty simple, kind of like the money. How the fundamental is, you borrow money into existence. You sign an IOU to the bank. The bank takes the IOU, and you know, now they create some money. They don't give you any interest. You give them interest, so that's not in a balance. And eventually, you go bust, or the people do, and the bank's own everything. Well, this system is not exactly that cannibalistic, if you will. But so anyway, we have these big, huge spots on the network. They call it the backbone. It's like it draw a backbone of like a skeleton, since it's Halloween time. So we're going to connect all this stuff is connected to each other, and this is called a matrix. So when it's connected back and forth on a big star kind of a thing, they call that a matrix. So let's say this goes down right here. What happens is this router goes, hey, I can't see that anymore. I can't go that way, so it goes off that way. And then it comes around this back door. Now you've heard about, oh, they're going to take the internet down and all that. Well, there's a lot of this stuff out there right now, and redundancy, power, and goes different directions. So it's very difficult to take this all down. And I'm going to say I don't think you can take it down. I think what you have to do is you have to have somebody inside that's really poisoning the well. And I would think that probably IT people would be blaming companies like Cisco if the internet were to go down. It's like, how'd they get into your code and how'd they get into your router? Your router's unable to change the backbone so the routing doesn't work anymore. But there's some other mechanisms. You've probably heard of DDoS, which is denial of service. And then the DD stands for distributed denial of service. So that's basically making a lot of connections, too many connections for your router to handle it. So you might be a business and you've got a router that's connected to the internet. Now those routers are more sophisticated than the little things you've got at your house. And they've got a lot more capacity. And so what happens is these devices will say, I want to make a connection. And so their other router or their host on the internet, host is just a PC or any computer that's on the network. And it will say, oh, I want to connect to that website at that location. And or if it knows your IP address, it could actually say, I want to attach to a specific IP address. And what happens a lot of times is the server will say, okay, I'll let you talk. So then it'll say, okay, he'll say hello, and it'll say, oh, hello, and then it doesn't say anything else. And then the device sends another hello, and it keeps doing that. It never actually says hello. It'd be like saying hello, and then hanging up on you as you pick up the phone. And then the phone rings again, you pick it up and go hello, and then they just hang up on you. And they keep doing this. Well, and you can only handle so many calls at a time until you have a problem and you say screw it, and humans will just throw it away, but stop answering the phone. Well, what happens to equipment is it can only handle so many hellos, and it doesn't hang up immediately. So now it's too busy saying hello to all these fake connections, and the people who are legitimate can't get in. And that's called denial of service. And they call it a DD, is 2 Ds, distributed. That's when more than one computer out there is doing the same thing. So basically they put malware or viruses on people's PCs all over the country, and then they have the software that says, okay, turn it on, and all those devices start trying to connect to the same site in the background. You don't even see it's happening, even if you're infected on your computer. But you could actually be hosting one of those viruses and attacking this website that they want to do. Now, the IT people are familiar with all this kind of stuff, and so they start doing things like, okay, well, that IP address is made 10. We got software that's watching. We saw that it's made so many connections. We're going to just block him. We'll put him in the penalty box over here. We'll take that address, and if it comes in and tries to connect, you just deny and ignore it. Don't connect to it. And it doesn't take much bandwidth to do a real quick connection. Not hardly anything. So anyway, this is the way it works in the big core. And your PCs and all that are down here talking to the internet. Now this is where we come back to talk about the Starlink, right? So Starlink comes in and it's got their big base station and they're connected into there like that. And they might have, this one might connect to more than one, but most likely it's got one link and maybe a backup wiring somewhere, just depending on where it is, if it's a big base. So these are Starlink base stations. Like they have a big facility they'll have somewhere, big old huge antenna stuff on top of the building or out in the country. And then your little computer over here, your piece, you're like you. This is you over here, and your little bitty teeny, thing with your laptop on it, and it's sending up the signal to the satellite up here, and then we're coming back down that way and go back and forth. Now, satellite is kind of slow, and I'm going to tell you how come it's slow. But anyway, this is how it all works. And so they're just connecting into this. Now, if this is down for a reason, like blocked, something like that, or you could actually interfere with this do radio jamming and stuff and stop this from working. Then it's going to be down. But your one over at home might be connected and still working. So even though this one's not working anymore, this one might be working. And then the protocol systems will try to take different paths. So to get you a feel, and then you have a telephone, your cell phone. Your cell phone There's a cell phone tower out here. You know, this big old tower. Out here, and it's got the little antennas up there on top of it. And here's you standing next to this with your little cell phone. Cell phone sitting there, and it's sending the signal up to the. And let's go up there, up to that guy. They're up the antenna, and this antenna is connected down to their company. It might be AT&T or whatever, and AT&T might have a local connection. And then they got a link back here to the AT&T spot right there. And this might be a Verizon. And then you might have, what's the other one? There's several of them. But anyway, and that's how they get to the internet. So their cell phone gets to that. And so this is how it all kind of works. And you just start building more pieces because you have the cell phone, you have the PC with the modem, and there might be a computer that's connected to that. And your cell phone could also connect, wirelessly to a Wi-Fi. It's got a Wi-Fi device in it. So let's talk about that for a second. And I'm just trying to tell you guys kind of how this stuff works a little bit so you can kind of get a gist of, well, if you want to be redundant and you want to be able to have something that's reliable, having the different pieces is really important. And, Wi-Fi is not some magical thing. We started putting Wi-Fi out in networks, I want to say, oh my goodness, let's see. I was still, this would have been in the late 80s, 88, 7, 88, 89, something like that. Well, let's see, was it even sooner than that? Y'all can look it up on the internet, but it's somewhere around that time. And we can actually connect our PC without a wire. You can map a drive, or we didn't call it. If you were Novell, we'd call it map a drive. And in Microsoft terminology, or an IBM Microsoft, it wasn't map, and we just did a net use. You connect to a share drive, share connection, a share name is what it is. But anyway, so let's talk about Wi-Fi for a second, because sometimes it's important to know what that is, especially in a system where things aren't running so good. So Wi-Fi is just a protocol for a radio signal. So your little bitty cell phone is running a standard that they have nicknamed Wi-Fi, and Wi-Fi goes off the IEEE standard, and they have a IEEE, and that's something electrical engineering. It's a big worldwide standard, and it's an 802.1 whatever, and then they have different letters here depending on speeds. They've taken this same thing and the speed that it originally was, and then they've added functionality and things like that to it, and so you'll have a N, W, A, F, all these other letters that used to go with that, and so then different devices support that. So what happens in your house? You have this little device. I'm going to make a pretty big one so you kind of understand what it is. Now, these pieces used to be separate. Everything was separate. The internet coming into your house was a serial connection, and it connects to, and cables still do this. Cable is a modem. The modem is in here. Make it. Let's make it neater. MODEM. So that's a modem, was a device. Now originally it was a box. Like that, and then the telco would connect into it with their wiring system, and then from this device you would then talk to another device, and you might be some type of an interface, and a lot of times it was a serial interface on a router. So you got a router, and a router had two sides to it. This side was Ethernet, which is a standard for wiring on local LAN networks and stuff. And then it would over here would have modem. A modem. Boy, that's terrible writing, but I'm telling you what it is. So it's a modem. So it had one originally we had two devices. Well, these all pretty much had one of those and one of those interfaces. And this would connect to the little network box where you put your little telephone looking things into. And your Ethernet cards into the device, and then your PC is out here. like that. And this was Ethernet. And Ethernet is a standard that was built not by, what was it, idiot? I mean, the person who said, Al Gore, he may invent the internet. And the internet's a network. I mean, come on, it's just a wide area network, so we call it. Metcalf, I forget the guy's first name, but he started 3Com Corporation. He's the one who invented Ethernet. And so this is what the device was. And then when they came out with Wi-Fi, they said, oh, we're going to be able to now, instead of doing it just this, we want to have little radios. So we put, which is this 802, this name right here. And you get this little device, and it's got little antennas on it. And in your little PC, instead of having a wire, you can have a little device with a little antenna on it. And your PC will connect to the network via the Wi-Fi. Now the Wi-Fi device has to be connected to the Ethernet network. And then the Ethernet network is connected to the modem. The modem goes out and connects to the other side of the telephone company's modem, and then they get out and they have more connections too. On the other end of this, where there's a server or something, it looks just like this, just reversed. So instead of a PC, or we call a PC or a client node, you'd have a server sitting here, and the server is what you're trying to talk to, and that's on the other end. So all this stuff is to get that signal from that PC over to that server. Now when you start putting a whole bunch of these together, it gets real convoluted, and so they called it the cloud. So the device at home, because the average person wouldn't understand all this stuff. And, you know, maybe I'm getting too technical, but it's kind of fun to talk about it, and you might or might not, you know, find it interesting. If you like Cliff High stuff, you might like this kind of thing. So, as you can see, we put a modem and an Ethernet network connection in the same box. And that one. So they just did all this stuff in one box is what they did. So you have the modem, you're going to have the switch, the Ethernet network, and then you have all those little spots that you can plug into. Usually there's, you know, 4 or 5 or 6 of them. And you can plug your PC in that. Then they would have an access point. See, that says Wi-Fi, but that's the Wi-Fi access point. So that's the access point. And it just means that that's the place they're connecting it into. So you put that in here. So now we got the little antenna on top of this thing. And so you have these connections here, you have a modem connection there, and then a wire comes in off the carrier. Now they've changed some things, and if you have cable modem, they might have a box still separate, and if they do, then you're going to have a deal connected to that. Now the problem here is that we need a router involved in this thing too. So I'm going to change this diagram up a little bit. We're going to move the modem over, and we're going to put a router in here. And then we have the modem piece, and then we connect to the telephone company that way. Now, so this looks like there's 4 little boxes here, but since everything is microcircuits and small stuff, they can squish it all down in a little bitty box. And you have all this stuff, is that these are the discrete functionality, and it's all passing through all these things, but it's just in one piece of plastic instead of all these separate little boxes with wires connecting to them. But it didn't look like this at first, because as they added functionality, they just said, oh, there's a new box, oh, sell that, because they didn't want to pay for a new one. So they would buy a piece here and plug into that. And the Ethernet box actually makes a little what we call local area network in your house. So you can put your printer on. So now we're going to hang off the Ethernet, we'll hang our printer off here. You know, so you can connect to your printer. And then they said, well, you know what we want to do is say, well, what if somebody doesn't have that, they just want to plug in, just print directly to it. They put a serial interface on it, they got a thing called a parallel interface on it, they got a USB port, and I'm getting interrupted. USB port connection, and then we're going to put in a Wi-Fi connection. So and then they charge you for all this stuff. So even though it didn't cost them hardly anything to add it on there, they charge a bunch of money. So this PC now, it can connect to this printer via Wi-Fi at the same time that you're connected to the internet, Ethernet. So if that wasn't connected right there, you still could print on your printer, and then you could do this. And then they have it set up so that, well, you know what, I have a PC and I got 2 PCs. I want to put 2 PCs on this thing. And I wanted that guy to talk to that guy. Well, the software, Microsoft and Apple and whatever, they write software that allows you to make that connection so you can share. And then they say, well, we want to back up our machines. So they give you a little hard drive thing out here, and they plug it into the Ethernet. And now your PC can see that and map a drive to it or connect to it with the software that's running on here. And then you can copy all your files. That's a little disk drive thing. That looks like a drum. Symbol and networking for hard drive is like that. It's a little drum. Because we used to store things on a drum. That's old school. That's why that symbol came from. But anyway, so as you can see, you've got all these pieces, and so they just squished everything down into this one little box. And then everybody they don't know any better, so they just call it the router. That's what they call it now, the big name router. And that one thing's there, and all this stuff is gone, except for your printer. Obviously, you still have your printer. They get rid of this stuff, and get rid of all this stuff because we don't need it anymore. Because now we're connecting directly to the router, the quote big router, the aggregate router, and the printer's talking to you, and it may or may not be using that little internet. So if you want to add devices and stuff like that, you just plug it into that wire right there if you don't want to do this Wi-Fi business. But the Wi-Fi is just a standard and connects to that. So people say, oh, I got Wi-Fi. Well, the problem is it has to connect to the internet. This is out here. This is our little cloud that we like to put. Everybody puts a cloud out there. And so you want to talk to internet. Well, if that's down, well, it doesn't matter. You got Wi-Fi. Your little cell phone. Your little cell phone. With its little antenna sticking out the top, kind of like this, but it says, oh, I got Wi-Fi. I got Wi-Fi. But he said no internet. Well, why is that? Because after it goes through all this stuff, it can't get to the internet because it's broken over there. Something happened to it. And this router, and so then they started putting security stuff in here. That's another piece that's missing. They added another device inside here called a firewall. And that keeps people from connecting from the outside. So whenever an IP connection is made, it says, hey, I want to talk to you. And the other side says, I want to talk to you. And if you're coming from the outside and this firewall, you say, I want to talk to something in here, unless he's got a rule to to allow you to get in, the rule is no, don't let it through. It just drops the packets. Only if there's a rule that says in here, I'm going to look at the traffic and say, oh, yeah, I'm going to let you in. And that's where they're vulnerable because they're actually looking to see. All they should do, if you want about the best, most secure firewall, but you lose functionality, is that it looks at the packets and it says, "Oh, your packet is not in response to a request." So the PCs in here say, "Hey, I want to talk to that server," and then it comes back to talk back to it, and the firewall knows, "Hey, that's a response to his request." So I'm gonna let that in because he asked to let it in. Anyway, so now you got a firewall in there too. And then there's a whole bunch of other things. Security devices that you can have in here. Data leak protection systems. Scanning, malware scanning. You're scanning your thing. A VPN. Okay, we can talk about VPNs. And I think, what's it, McAfee. He's got a video out there. And I think, we don't know if he's live or not. Supposedly he's dead. And he is saying, oh, and VPNs are just not, they're bullshit. They don't work anymore. Well, that's true and it's not. How much time we got here? 21 minutes. That's not too bad. Plus I got to tack together. So VPNs, everybody, y'all are always hearing about VPNs. So anyway, you see all this stuff. Well, then they kind of they might actually put in a VPN device, circuit in here, so that when it goes out, before it goes really out, would probably want to route. Let's redraw this a little bit. So we have our Ethernet switch over here, and we've got our router here. You know what? We're going to put VPN there. Let's go ahead and make the box this big. We got modem, and then we've got firewall, VPN, and no, you don't have router, and then VPN. And put the router first. And VPN. Okay, so what does a VPN do? A VPN sets up an encrypted connection between 2 points. So this device is talking to another node at the other end that's running the software that allows this device to connect to it. And in those 2 devices set a encryption between each other, and they take all the communication coming from here that's going to go to that other location, and it'll encrypt it and send it across. So if anybody's out here with a tap, they might be tapping on here and watching all your data, they can't see it because it's encrypted. Now there's different levels of encryption, and then there's probably some shenanigans behind the scenes where governments paid some of these VPN vendors off. And sometimes for the free VPNs, most likely it is the government who's doing all the free VPN stuff. You don't pay for it. Somebody's getting paid somehow. So, and what McAfee's trying to say is that, hey, we got a malware on here already. And before you ever encrypt that data, it comes out of your cell phone or your PC, and you might have VPN software right here. You might not be using that VPN. That VPN may not even be there. So you put VPN on your phone, and then before it leaves your phone, it's encrypted. But while it's in the memory of the phone and the processor's using it, it's not encrypted. And that's what he's saying. If you've got a malware device or something on this in this machine, whether it's a PC or a phone, doesn't matter, and it's malware and it's watching all the traffic before it gets sent to talk to the VPN software to encrypt it, it already captured it. And then it sends it out. It might use your VPN, come VPN to its own self and send your own data. Now, if that's happening to you, your phone's going to be real slow. And all your communications are always going to be terribly slow. So you can usually get rid of those malware and just, blow the whole phone away and reload everything. There is a danger with using cloud-based backup, and that is you back up the malware. That's not good. So anyway, that's what a VPN does. That's all it does. It just says, hey, I'm going to do this. Now, at the other end, they're saying, oh, they can be private. You're going to be private. Because when you talk to a website, it can see the IP address of where you're coming from. That's part of the information when they're trying to communicate with each other. Well, here's my number, and so you know where I'm coming from. And so that way you can answer back. Because the internet's got to know how to find you to send the data back from the person or the server or machine or whatever you're trying to connect to. So it has to do it that way. And so, that's kind of how things work. And, I think that in the comments, you guys want to talk about some stuff or ask some things or say, oh, well, I heard something else is wrong. That's not the way it works. Or, maybe I mistook something or left something out, which is, there's a lot of pieces to this. But that's what he was talking about when he was saying that those aren't obsolete now, because once you get in here, you got it. Well, that's always been the case. If you had the VPN here for the whole company, and they had to go out to another site somewhere, and the reason it's private to the world is because somebody else at another location has got a VPN. And when they bring your stuff and decrypt it, then they turn around and send it back out on the internet to the website. And when they do that, it's using the IP address on the VPN system for them to connect to. So it says, oh, well, your name is this, and you're in Mexico, so or wherever you are. So I'm gonna just since that is something that's talked about all the time, and everybody wants to know about VPNs, we're gonna just talk about it and go over it kind of easily so you can see it. So here's you over here, and you have a VPN connection software on your system, and you're going to go browse a website, and it knows that it's going to do HTTP. You've seen that, you put //HTTP, and then S means it's secure. But let's just say we're not doing the S. So VPN, and S, it means it's encrypted. So the VPN software takes this HTTP connection with your IP on it, and it sticks it into this thing, and it just builds out a little tunnel that encrypts it over here to the other VPN. And this one might be, and so let's say then here in USA, and this is over in Germany. And let's say that the server you want to talk to is in I don't know, whatever, China. All right, and here's the server down here. So what happens is it takes your HTTP request, puts it in this VPN tunnel, encrypts it, sends it over here to this guy, and he acts as a proxy, and he forwards that request to this. And so that China sees the IP address of this VPN in Germany and thinks that you're in Germany, because they have a geolocation for all the IP addresses. So he thinks you're in Germany, so he says, okay, I'll talk to you. Because they don't want to talk to you because you're in the USA. It's supposedly the freest country in the world, and you know we can't. You got to give all your information and know your customer and all that kind of stuff. So that's stuff we need to fix all that. But one of these days maybe we will. The bad guys win. So anyway, that's what the VPN does. So does it make you 100% anonymous? Yeah, I guess it does. It's not really, doesn't know that you're where you are. And the question is, who owns the VPN software? You know, there's some issues with that, and that's a big deal right there. So I hope this was a little informative, and I hope you guys enjoyed it. If you want to know more about networks and computing and stuff like that, you know, I'd be happy to talk more about it. I like to talk about this stuff, and I just picked up some stuff out of the air here to talk to you guys today. And I hope you enjoyed it, and I hope you check the like and subscribe buttons, forward it to other people that you think they might want to know some of these things. And if you have any topics you want me to talk about, I'd be happy to. I know a lot of stuff about a lot of crazy stuff, and I like talking about it. And as time goes on, you're going to continue to see, I might have some things to talk about. And one of my favorite people is, and I've mentioned him before, and that's Cliff High. Cliffhigh. Everybody always kind of wonders if that's really a real name or not. But I guess if Sam Bankman Fried can be a real name, I guess Cliff High can be a real name. Anyway, thank you very much for your time. I hope you enjoyed it, and y'all have a great day, and we'll talk again.